In JavaScript, if you were asked to write some code that will print out numbers 1 through 5 in sequential order with a 1 second delay during each printing of a number. Typically, to accomplish this task, um, well, one way to accomplish this task is to create some sort of loop and then call set timeout. And if I wanted to print out every character in this string with a 1 second delay, and the reason why I'm using I multiply, the incrementer multiplied by the time, is because every iteration we're delaying it to when I print out, say, the letter B or the character B, it will be at 2000, C will be at 3000, so on and so forth. The reason I have to go through all of this is because, unlike Java, which has a sleep method to pause a thread, you cannot do this with JavaScript because JavaScript is a single threaded runtime. There's only one thread of execution. C Sharp also has a thread sleep method, and Rust and C++. This is Rust and this is C++. For a thorough explanation of how the JavaScript single thread runtime works, I recommend this video. What we could do in JavaScript to work around the fact that it's single threaded execution is that we can create our own sleep function as a utility function using promises. Let's do that next. Because of the single threaded nature of the JavaScript event loop, we have to implement concurrency slightly different in JavaScript than in other multi-threaded languages. Fortunately, JavaScript gives us multiple mechanisms to sort of implement our own version of concurrency in a single-threaded runtime, one of which is the classical callback pattern, which is pretty solid, but is cumbersome and very verbose. And because of its verbosity, could lead to potential errors and bugs. The other is something called generators, which is a very sophisticated pattern. Unfortunately, generators are not fully supported in all browsers as of yet. So that leaves us to something that is quite tried and true and better than the callback, and is the concept of the JavaScript promise. Now, you can read up on JavaScript promise at the Mozilla Developer Network here. Now, keep in mind, please, that MDN or Mozilla Developer Network documentation is not the official documentation for ECMAScript. The official documentation for JavaScript is at the ECMAScript specs. Now, to me, the MDN documentation is very readable. It goes in depth, but not exhaustingly so, like at the official spec, and it doesn't gloss over like a W3C school. So it's a fine balance. Also, the creator of the JavaScript language, Brendan Ike, used to be the president of this company. Now, does that make it better? Absolutely not, but certainly it's one option, right? And certainly, I want you all to have agency over your own learning choices. This documentation here is only one of many. So let me just read the first sentence of this description here in the docs. And to me, it pretty much sums it all up. A promise is a proxy for a value not necessarily known when the promise is created. Okay? Now you can read the rest of this on your own, but to me, the first sentence makes a lot of sense in my brain. So let's just write a sleep function here, and I'll explain afterwards. This is sort of like my own version of Hungarian notation. The input would be some sort of time, and the data type would be a number. And I'm going to return a promise. Promises, of course, are constructor functions, so I'm going to have to new it up. And then it takes two functions that can be passed in as argument, because JavaScript considers functions as first-class citizen, and therefore you can pass functions as arguments. You can call these callbacks whatever you want, but typically the first argument is always the resolve function, and the second is always the rejection handler function. And then we can call set timeout. And we can see this before. I don't need the curly braces. Get rid of that. And for set timeout, all I'm going to do is I'm going to just pass in the resolve, and you guessed it, the time input num. That's it. That's the sleep function. I'm going to explain how we're able to do this. Okay, just let me now. Keep in mind that because my sleep function is returning a new promise, when you call sleep, you can chain on the then method to it as a callback as well. Okay. Now let's write a function to print out 1 to 5 like we did before, using the sleep utility function. Okay, so in a real app, potentially this will live in some sort of utility file, right? And then you can import it and then call it wherever you need it. Now, you might have seen async await out in the wild. Async await is nothing more than an abstraction of promises. Okay, you can call it syntactic sugar for promises. Now, since I'm going to implement a promise function, I can create an async function here. Let's call it print delay. Okay. And we don't need anything like that. And we're going to have a for loop like we did before. So to start with 1. Now we can call the sleep function here, but because I have an async here, I can call await. Okay, await. You can think of await as then. Okay, it would be 1,000 milliseconds, just 1 second. And then we'll get a console.log input You can put I. Just put I here. Okay, let's go to the console. Let's save this, and then let's call this function. Okay, and now let's print out all the string, all the character, all the char in the string. So we can change this to 0. str.length plus wait string sub I. Okay, now let me explain in as little words as possible as to why we can achieve this in JavaScript. Again, going back to the Mozilla Developer Network documentation. Now you can read this yourself, but I want to highlight 3 bullet points. Okay, 3 bullet points. Now, in JavaScript, the promises offer certain guarantees, right? There are obviously very few guarantees in life, but JavaScript, in the JavaScript world, when it comes to promises, we have certain guarantees. Callback added with then, remember, then is a wait is just another word for then, syntactic sugar, will never be invoked before completion of the current run of the JavaScript event loop. These callbacks will be invoked even if they were added after the successful failure of the asynchronous operation then the promise represent. Multiple callbacks will be added by calling then several times. They will be invoked one after another in the order in which they were inserted. Okay, so to me, these 3 bullet points are the most important part of why this is working in Java. So obviously, the print delay does not have to be so static, right? You can certainly make the input more dynamic like I've done here and get the same result. Okay, well, if you're not a subscriber yet, please consider subscribing if you like my content. For those of you who are a subscriber, thank you very much for being a subscriber. Also, a I have a video showing you how to handle promise.all errors. I created about 3 years ago. If you want to learn how to do that, please check out this video. Other than that, I have to consider what type of graphic I want to put for this video. Maybe narcoleptic person holding a shovel or something. All right, thanks for watching. See you next time. Bye bye.